Good afternoon, everyone. So I'm up here today to share about tooling in Swift. So I'm Stan, also known as LXReorderableCollectionViewFlowLayout. Some people know me through the projects that I create, release open source. Usually they are prefixed with LX. So I would like to start with this quote. What we do today can be automated tomorrow. This quote is said by Douglas McRoy. I gave a talk 2 years ago with the same quotes. It's also about CI. I gave it on the iOS conference. Not conference, I gave it on the iOS Scouts. So this is kind of like a continuation to that talks. I revisited quite a bit about CI, and there's really a lot of improvement in these areas I would like to share about. So along the way, we also build tools with our new found toy, the Swift language, and to help us in developing, getting things done in our CI servers. So the key of these quotes is automate. And there's like about 4 main types of automation I would like to talk about. The first is automate transformations. Usually they are data to and from, for example, machine readable to human readable codes. It's really this kind of automation really enables scalability in the sense that when it comes to, for example, processing large amount of data, if the inputs are done in like some web form and stuff, we can easily automate it into machine readable forms and vice versa. So the second kind of automations that I like to talk about is abstractions. It's like programming paradigms. It's ever evolving. So we came from C, which is functional, to Objective-C, which is object-oriented, and now we are going to Swift, which they are proposing something called protocol-oriented. So abstraction helps us increase our contextual bandwidth, so we can develop much complex software, and it also helps us increase our ability to understand or describe our problems. The third kind of automation I'd like to talk about is flows. Flows are natural flows of events. So we usually visualize them as like graphs, directed graph. I'll give you an example later on of what I mean by flows. Flows, it shows us the choice, but at the same time it also shows us the limited choices we have. So if it's a directed graph, we have like 3 edges, then we have 3 choices. We don't have like n number of choices that we don't know. So example of flows are like build automations, like go for compiling to linking to testings and stuff like that. And another kind of automations of flows are dependency management systems, because you will have dependency is by itself is like a graph, so it looks like flows. So the last kind of automations I like to talk about is error detections and preventions. Useful in highly error-prone environment, usually like collaborations or you have shared resources. that. So if there's someone breaks something, it will cause cascading effects. Things like Gits, like you can't merge without resolving the conflicts. They prevent you from doing those things. Another example is like continuous integrations. They alerts you. Test is also a kind of automations. They gave us confidence to do a lot of things. So the first thing I'd like to talk, the first concrete automation I'd like to talk about is builds. Builds. There's we have quite in the iOS landscape, we have quite a few things to help us do automation of builds. So there's basically three kinds of build systems. The first kind is on-demand. So on-demand is basically like you write the scripts and stuff like that, and you run it, and then you do all the build system, maybe bumping the versions, like running the Xcode, and then at the end of the day, you package the IPA files, distribute, send it to the servers and stuff like that. All these are done with just one or two commands. So there's a lot of tools available out in the open source. Most of them are surprisingly like backed by Ruby. The most notable ones are Nomad, and then Fastlane. I'm not sure how many people use Fastlane, but it's recently just I think like yesterday or the day before just acquired by Twitter, the Fabric team. So the other two kinds of build are scheduled and triggered. So scheduled is like scheduled builds are like nightly builds. So they get run at a specific interval, like maybe 1 a.m. in late night. So they usually try to build a working snapshot of the app of the system, and then they try to keep like a working copy so that someone could actually use it, or like they can get the latest developments of the app. Usually they can be stable or unstable, but they have to be compilable at the very least. And triggered ones are when like it's done at every commits. With like if you have multiple people working on the same system, or you have maybe a core frameworks of your apps, and then you have multiple apps using that core API, and a few people are making modification to that core framework. Having set up a triggered build, or they call continuous integrations, will help you prevent like someone breaking the change, or someone breaking the whole your other apps and stuff like that. So those are scenarios where having continuous integration is a pretty good solutions. So some of the tools that are available for this kind of scenario is like Xcode server and Travis CI. Circle CIs also have server, also have such service, but they are betas. So today I'm going to focus on Xcode server. I will have a few I will have a few demos. We will walk through on the process of setting up continuous integrations and write some Xcode Swift tools and Swift scriptings mostly, and then try to get some tasks done. So the first thing is that you have to buy the OS X server at $19.99. So you have to spend $19.99 to have the ability to have a Xcode server running. So if you have a spare machines, this is actually a very cheap way, because if you actually look at the plans of like Travis CI or Circus CI, they are not cheap. So I'll walk through very fast like some of the screenshots. And then, so this is how an Xcode server looks like. This is usually the control pan. This is where the Xcode, this is the Xcode setting panel. So as you can see, there's a lot of information. And the most important thing is just the button on the top right side, that green button, because you have to click it, and then you have Xcode server. This is where this is inside your Xcode under the accounts. You have to set up, after you set up Xcode server, you have to connect it in this place. So if it's local, you will specify the local address, and then you will enter the username and password. I leave it out for security reason, and then after you've done that, you start creating bots. So in Xcode server, you create bots to run integrations. So each bot, so you can create like multiple bots for a single projects. But each bots will be configured differently, so they can have different behavior. So some of the things that you can configure is like just now I said, you can configure on commits, or you can have it scheduled periodically. And then this is a pretty important panel, because this panel actually allow you to implement custom scripts into your integrations, which allows you to do quite a few things. I'll show you in a while. So we'll attempt to set a continuous integrations on these projects, the Hacker News Reader by I only have his short form name, so but I'm going to show the demo. So the first thing is I'm going to launch the. I'm going to launch the Hacker News page. Oops, it's not showing there. So basically, this is a Hacker News Reader. It's an open source project. If it's not written by me, but I think it's a pretty nice project. So I'll just launch it once to show you how it looks like. Maybe on the 5. And then after that, I'll create a Xcode. I'll walk through creating the Xcode bots. So it'll take a while. Okay. So this is how the app looks like. It's pretty nice, and it has some tests. It uses CocoaPods for dependency management. So you have things that I want to show. I want to test to show you guys today. So I'm going to close it. And so the first thing is that if you go to server, and then if I launch this, this is where you access the first panel that I show you. So what you need to do is you just have to turn this on. This is probably the only steps you probably have to do for here. So once you turn this on, you can create a box by doing this. So we can call it like Hacker News Reader Nightly Build. Let's call it Nightly Build. So you just click next. It will do its normal like configuration stuff. Oh shit. Okay, I have one. Basically, you go through this. I have one. It will look something like that. So you will set up the repository. Then you will reach this page. You can schedule it like periodically on commits. And then after that, you can decide what device you want to run on. You can actually select all the simulator and the device you have. And then lastly, the triggers. So this is, and then once you are done, you'll be able to see in here. So in order to run your test, you basically press the integrate button. Each test are called, actually it's not tests, but it's called integrations. Basically, they do analyzing of your codes. They run, they compile it, they run the test, and then they will report to you. Like here's the place where they will report to you how that build went about. So this is if you have like integrated Coca pods and you have not committed your pods folder, your integration will definitely fail, and this is the failure result. So this is how it will this will be its failure result. So it will give you these errors like no such file and stuff, and then it will say that you have to do a pod install. So we use Coca pods for automatic dependency management. I know some people might not like Coca pods. It's actually pretty good if you know how to use it. I'll show you later how I use Coca pods for importing libraries into the scripts. Like libraries, other people write libraries I written. So in order to solve the Coca pods problem, the first thing you can do is that you can install your Coca pods in your global space. So you basically use a sudo gem install Coca pods, and then you just in your pre-trigger you just do a pod install, and then things will be fine. And then things will run, and you get your integration done. But sometimes we don't really want to use the sudo. And then if we doesn't really want to use the sudo, how are we going to do it? The key is that all integrations are actually run by the user _xc build d, likely a acronym for Xcode build daemon. So we need to set up Coca pod in user space. And so we'll have to write a lot more scripts if we want to get it working. Basically, don't worry about reading the scripts. I'll publish all these materials later. Basically, what it tries to do is that it set up the environments, like it export the length, and then it tries to patch the path variables, and then we install CocoaPods in the user space, and then we cd into the working directory and we do a pod install. So, here's a demo. Where's my? So you just have to click edit board and then go triggers. I have already set this up for this. So can I make it bigger? Okay, so basically, this is the scripts that I have written just now. I have written on the slide just now. I probably can give you in a better format in here. Scripts pre-trigger. So it's something like that. Can I make it bigger? No. So basically, that's the script we put in the pre-trigger, and then what it does is that it will, if we go to our logs, in our first before trigger, so what it does is that it will try to install CocoaPods, it will update the local dependency, generate the pod file, send the states, and then we are done. That's what it does. And then after that, it will execute your build. It will execute the build, and then these are all done automatically, as either through pressing the integrate buttons or like on every commit or your scheduled time. So oops. So Xcode server does come with a web version. I'll show you that in later. And then we gotten so now we gotten the integration done, right? So now we focus on like doing up a nightly build. What's a nightly build is basically we schedule it at like maybe late at night so that no one is working on it, and then we try to build. We try to distribute out a working version of the app every day, and then so that everyone can have a snapshot of the current development of the apps. So we just went through integrations. So there's three more things that I want to focus on: versionings, commit and tag, and distributes. So we want to automate versioning. So versioning usually for iOS developer, most people use the Apple generic versioning. So, and it comes with its own tools. So AVG tools. And then usually it have two kinds of versions, one for marketing and one for internal. The marketing one is the CF bundle short versions, and the internal one is CF bundle versions. But I like to bring to the attention of everyone is that the versioning is actually inconsistent across multiple Apple apps. So like for example, Xcode, you have this 7.1, this is the latest, and then you have some arbitrary text behind. So if you actually dig in, the short version string is 7.1, the bundle version is 9079, which is not found anywhere here. It's only the product build version that is being displayed. So if we move on to maps, you will see that maps have two. You have bundle short versions, which is 2.0, and then the bundle version, which is like a dot separated dot separated values with 3 components. And then here's the Xcode server, which is the short version have 3 components. The bundle versions is arbitrary number, and then the bundle build version is some random strings as well. So what I'm trying to say is that there's no specifications. It's very inconsistent. If you actually study, like, there's no version graph. What do I mean by version graph? I'll show you an example of version graph later. So it's not very expressive as well. Like, if you were to implement it, like, how do you differentiate between betas and alphas and stuff like that? No, like, those numbers means nothing to the users. And the AGV tools doesn't support Git. That's not a big problem, but I just want to point it out. Then there's no versioning for the marketing version, meaning you actually have to enter the version yourself. And then there's a limited versioning for the internal build versions. So what does I mean by limited versioning for build internal? So if you run this command, agv tools next version or bump, only the first one will succeed. You can't do the second and the third one, although they do make sense. Like, maybe you just want to bump the middle component, or you want to bump the last components. These are things that we might do, but the AGV tools doesn't support those things. So if Apple generic version is not something that we really like, what we can use, I suggest we use semantic versioning 2.0. The reason for using it is that if you use CocoaPods, most of CocoaPods is managed by semantic versionings. Carnage also use semantic versionings. It have proven to be very effective in dependency management and version control. So this is the solution I would go ahead with. So a semantic versioning components is made up of major, minor, and patch, and then with a dash, followed by a pre-release dot separated values, then followed by a plus and a metadata, which is also a dot separated value. Pre-release and metadata, they are optionals, but they can be very descriptive when we want to distribute alpha builds. So just now I mentioned what is a version graph. A version graph looks something like this. It looks scary, but it's actually not that scary in the sense that every arrows points to possible next version for that from previous versions. And then even though they have even if they points to 3 arrows, between those versions that it can go through, they have orders between them. So they have, so they actually flows systematically, and rather than randomly just you can bump this number up, or you can't do any bumping of other in between components and stuff like that. So those are very limiting. So to support this, semantic versioning, I wrote a code that help use parse and model semantic versioning to help us write scripts later. So in order to use it, we have to use a CocoaPods ROM. I can't use Carnage because Carnage currently doesn't support Swift 2.0. So CocoaPods is the only solutions. In the pod file, you just have to have plugins and then pods, and then define the pods, and then in your scripts you have these shebangs that provides the most important is the f-rom. That is where you are telling the Swift scripts where to find the frameworks. So I'm going to show demo codes.
Sure. Oops. Okay.
So this is the script I've written for semantic versioning. So what it does is that it bumps the versions based on it can bump individual version like major, minor, patch, or you can bump the pre-release. It actually supports the standard semantic versioning system. So if we go to here and we write, like, we go to the scripts. Shit. Oops. So if we run like samver, we say like 1.1.1, and then we want to bump like major, then it will give you back the major version. If you just want to bump like patch, it will give you back the patch. And then if you have like alpha, and you just want to bump the pre-release, it does, pre-release, it does bump it. So it's pretty useful if you want to build like, it can be a very good tool for building like versioning. What's interesting is that it's actually a script. There's no compilations done. So I'm just executing the script from here. As you can see, I'm importing custom frameworks like my own, LXMver, and the commander. So we can actually build script like this. So as I'll show you more later. So we are going to write. We are going to do similar, but we're going to script nightly triggers. For pre-release, we will always tag it as nightly, and then we will retrieve the project version from info plist. We keep a counter called LX nightly build version. So how are we going to read the info plist? I built another tool to do that as well. So it's called, it uses, it spawns an NS task, and then it executes some of the existing tools that Xcode provides. So we pass the output of the Xcode build, and then with the settings, show build settings, and then we'll use that to get the info plist information from the project, and then from there we'll read the plist, we extract out the versions. So what it looks like is, oops. Scripts. Oops. Sorry. So, how it looks like is this. The main thing is this Xcode build settings, where I actually read the workspace and the scheme, and then what this Xcode build does is that it will actually use the Xcode. It will actually use the Xcode tools to extract out the build settings. If you go to the port file, you can actually see it in actions. So basically, it's running these commands using an S task to run the Xcode build, and then after that we pass the value in with the above commands. So how will it look like is it will be something like this. So I need build versioning. So if you look at right now here is nightly 3, and if I run this command again, it will change to nightly 4. So these scripts basically what it does is that it just keep bumping the versions. You assign it like the nightly tag, and then keep bumping the version behind. So now it becomes nightly 5. So once we have these scripts, we just go to our integrations, go to our triggers. We add it as our second trigger. Basically, we just cd into the script directory and just execute that build version. So these are not compiled code. These are all Swift codes. So okay, I'm running out of time. Shit. So another thing I would like to bring out is there's actually even more interesting techniques to do is we can actually make use of Xcode framework, like DevTools core. These are frameworks that Xcode use to load projects and stuff like that. So DevTools core is a private framework. We actually have to generate our own headers, import the framework into Swift by defining a module with module maps. So to generate headers, we use class dump. Basically you use class dump to dump up the header to give you a sense of what are the possibilities, and then you can just partially declare your headers. You don't need to define the full headers. Just declare what you need. And then this looks very small, but basically you create, then when you want to define the module map, you create the umbrella header, and then after that you define the module maps. So basically you say umbrella header, then dev2 cores, and then you link to that frameworks. So Dev2 calls come with a lot of dependencies. So you have to identify their dependencies by using O-tools and using the L commands to find the dependencies, and then once you find the dependencies, you can just use the following commands to first bring the module with the I options. The F options is to provide the framework search path, and then the framework, all the framework there is the dependency of the dev2 calls. After which you can just do an import dev2 calls. I'll skip the demos, but I will post the codes later. So basically, the cons of semantic versioning is that it cannot be submitted to iTunes, so you cannot do test flight and stuff. But we can use like Questionlytics or Hockey apps. So and sometimes you don't need to wait for test flights. So basically, we have done nightly builds. So we done versioning and integrations. Then the next step is to do commit and tag. So to do commit and tag, we just run it as bash scripts. So we provide the version, and then we commit, and we set upstream, and then distribute is similar as well, in the sense that like distribute is basically depend on the channel you distribute to, but basically you take the SCS. You can use one of the environment variables to retrieve the archive files. So with that, we actually able to set up a nightly build. Sorry, I run out of time to show you the demo, but I'll post up the script. So the last thing that I actually want to show is code generation with Swift. So code generation with Swift is we can use it to set up. Sorry, we can use it to set up. Give me a while. We can use it to like create extensions for protocols, and sorry, very fast one. So we can use it to set up for protocols by like image protocols, and then these are the codes that we use it to set up for the image protocols. If we run the command, it will go into the asset catalog, and then it will generate codes this way. So you can actually use Swift for a lot of things. And then, oops. So finishing. So the other things is that Xcode server is written in Node. So you actually can go into it and run it and check out how it's being set up and stuff. And then lastly, setting up, doing all this automation. Sometimes you felt that you're going to save a lot of time, but actually you end up spending more time developing the tools than you save the time. So sometimes it might not be that worth it. Yeah. So, but yeah, that's all. Yeah.